Okay, good evening, welcome to
FamilyMath557.
FamilyMath557. Yesterday we talked about the difference between this expression, x squared plus y squared, and this expression, x plus y, quantity squared.
Okay.
So today we're going to do, hopefully a fun little project of trying to guess if I made a 3D graph of this equation. So first the z value is just equal to x squared plus y squared.
Okay.
What that might look like. And the second one, z equals x plus y squared. What does that look like? And we're going to see, like, you know, are they different? Are they the same? What do these equations look like? And I need to plot them in 3 dimensions to show you what they look like. And so what we're going to do is we're just going to zoom in on a square here. So x is going to go from -2 to 2. Y is going to go from -2 to 2. And we're going to try to imagine what this looks like as you go up. Okay. Which one would you like to do first?
How about x squared plus y squared?
Okay, so we're going to look at x squared plus y squared. Give you the pen.
Well, I know of an equation that is a similar form to this. That I don't know will produce the same result.
Okay.
But this is an equation of a circle happens to be r squared equals x squared plus y squared.
Ah, interesting. So if r equals 1, for example, we would have x squared plus y squared equals 1. What would that look like in our square here?
So that's a circle, I think, centered at the origin. Radius 1.
Radius 1, okay. So if we were smashing our map, our z equals x squared plus y squared graph down, this would smash, the circle would be part of the graph. But instead, in 3 dimensions, it's going to be up. And how high up is it going to be?
It's going, well, in this case it's going to be 1.
1 up.
So it's going to be a sphere?
Ah, interesting.
Maybe.
So, but we do know one part of our graph, the part that's 1 up from the xy plane, is going to be a circle, because you recognize that x squared plus y squared is the equation of a circle. Now, can you tell me a different point other than this circle that's 1 up, a different point that's part of this graph, z equals x squared plus y squared?
Z equals the origin right here.
Ah, okay. So how high up is the origin going to move?
None.
None. None high. So we know another point here. We know 0, 0, 0.
That works for our equation.
Works for our equation. And when z equals 1, all the points who have a height 1 are going to be on this circle, x squared plus y squared equals 1.
Yeah.
Okay. So what do you think's gonna what do you think now that you know there's a circle sort of 1 up and there's a single point that's kind of glued to the xy plane? What do you think this is going to look like now?
Well, I think this is going to be sort of a 3-dimensional version of a parabola, because as you go up, you're still going to have circles. Like, if there's 2 here, you still get values for x and y that work.
Okay.
You get some circles that go up, but it's going to start as a point, sort of get bigger and bigger circles.
Okay. What do you think?
But the circles are going to keep getting bigger.
Well, yeah, because if you make z go up, you'll always find values that work. So it'll just sort of kind of looking like a parabola.
All right.
I'm going to revise my guess. Are we looking at only positive values?
Of what?
Of this function. It's like positive values of like r here to make parts of our equation.
Well,
because r equals -1 produces the same circle with the same xy coordinates as our r of +1. So maybe there's 2 of them meeting at this point here.
Ah, interesting. Okay. Now, I just said here for our equation, z equals x squared plus y squared.
You can't have you can't have z being negative.
Because x squared plus y squared have to be both positive or 0.
Yeah, so it's interesting. If I would have said z squared equals x squared plus y squared, maybe I would have had some positives and negatives.
Yeah.
And maybe we could look at that on the computer afterwards. But great discussion, guys. Let's move on to this next one now.
Okay.